Hi, folks. Ooh. How are you all doing? Good, good. I am not loving the weather, but that's okay. Yo. Hello, hello. Awesome. All right, those of you who took the makeup test, how did that go? Better, hopefully? Good. Okay. Oh, sorry, Skylar. Okie dokie. Forget your calculator, oh no. Okay, that's good. All right, well, today is our second to last class. It feels really weird, but we're almost there. So we are going to continue our journey through the wonderful world of waves. Yeah, makeup for the makeup. Sorry. Okay. So we've talked a lot about one wave, and I think that's been great and interesting. Now we're going to talk about what happens if you have two waves. Passing through. Well, let me write. There we go. Passing through the same space. Okay. Two waves passing through the same space. What do you think happens if you have two waves? Say you have a wave. We're just going to do a little wave pulse going this way. And we have another wave pulse that maybe looks like this going that way. Stronger or cancel out. Yeah. They add. Yes. They add up. The displacement, this one will have some equation for the displacement. This one will have some, I'm going to call this wave 1, this wave 2. So the result will just be how far one of them is above its equilibrium plus how far the other one is above its equilibrium. Forces on the particles combine, yeah. Mm-hmm. It's kind of the same idea. So acting constructively or destructively, yeah, that's where we're going with this. So I have a little animation that I found that I think is very cute. Well, very educational, right? So you can see how they just sort of stack on top of each other. It's cute, right? I don't know why cute is the right word for this, but it is. But you can see how they stack up on top of each other. I don't think there's a way for me to make one of them negative. Maybe there is. Pause. What happens if I do this? Aha. What do you think will happen with these two waves? Subtract, subtract, cancel. Yeah. You're still adding, but one of them is negative. So yeah, cancel sounds good. Let's see what it looks like. Meow. Ooh. Looks pretty cool, I think. It's kind of mesmerizing. So if you are interested in playing with this yourself, It is ophysics.com. w2.html. It is kind of weird. Let me make it slower. There it is for Twitch as well, if you want to go play with it. Okay, so this process, let me see if I can pause this at a certain moment. Okay. So you have the height at any given point of the blue one, which would be like +2, and then the height at that moment of the red one, which would be like -2 and a bit, and the result is going to be negative that bit. Okay. So this is called superposition. And it's you just add them up. This is not bad. Okay. That is all making sense. What about if you have, let's think about if we have a set of two-dimensional continuous waves, right? So they make that sort of those outgoing rings, right? So we have outgoing, pretend that's a circle, right? So here's one wave that is coming from this source, number one. And then we have maybe another source over here. Something like this. Okay. So this is like frozen in time. But for one-dimensional, for two-dimensional or three-dimensional wave, you can say 3D, doesn't matter. Each of these, each wavefront is a crest. Right? So if we took some line, it would be like there would be a crest here, trough here, a crest here, a trough here, crest here. It's gonna be kind of like this, right? Does that make sense what I'm trying to draw here? Same thing. I can pick any axis, right? No matter which one I pick, there's going to be a crest here, a trough here, crest here, trough here, crest here, trough here. Okay. Wow. Pretend I can actually draw a circle. These are not great. Okay. What is happening at this location? Location A. I have two crests, crest combined. Two crests. So they combine. So I get one like this plus one like this. I get double crest. Double crest. Right. What is happening at, let's say, B? Double trough. Trough plus trough equals double trough. Okay. What is happening at C? straight line, zero displacement, right? Crest plus trough equals nothing. Okay. So this is kind of making sense. Yes? No? Ooh. Twitch got dropped for a little bit. Okay. So, all right, let's do good. So this process is still superposition, but it's also sometimes called interference. The pattern it makes is an interference pattern. Interference. Okay. And let's say we want to put some math on this. Let's add math. The key idea is phase, specifically phase difference. If you were doing an interference type problem and you're not finding the phase difference, you're probably doing it wrong. Phase difference. Right, we talked about phase in previously, like Tuesday. Let's add math. All right. So if we have let's do a little bit of review. Maybe I can do shapes, then that will suck less. Can I do? Oh, they're just all going to be ovals. Nope. Look at the shape. Like an egg. Close enough. Okay. Pretend these are circles. Here. Here's our center. Okay. So the wavefronts are crests. And we did a few exercises. I think that should work, but I have my keyboard folded down. So I'm going to be lazy and not do it. So we talked about finding the phase difference between 2 points from the same source, right? So let's say this is point D, this is point E, this is point F. Can you tell me delta phi from D to E, delta phi from E to F, delta phi from D to F? So this is, do you remember what we did on Tuesday? This is our source right here, source number 1. Okay. Skylar says D to F is 2 pi, which is correct. Crest to crest is 2 pi, one complete cycle. Annie says D to E is, yes, just pi. Good. Because it is crest to trough. It is tempting to think, oh, it's half, so it should be pi over 2, but it's half of a circle, which is 2 pi. How about E to F? Yeah. Over on Twitch, Logan and Gabrielle, this still making sense? Yeah, excellent. Okay. That's 5 between 2 points. Okay, so can you guess what we're going to do if we have, you know what, I'm going to draw the circle. It's the shape. Can I pick this up? No. I don't want it to be there. I'll take it away. Nope. Trying to make it like an actual circle, but whatever. Okay, here's source one. And then I'm going to do a different color because I feel like it. Over here. Why am I offset? It's because I can't draw circles, is why. It might just be this that's not doing it right. Okay. Pretend those are, this is really bad. They're supposed to be the same wavelength. So I'm gonna like try to make them. I'm gonna try again, and then if it doesn't work, I'm just gonna give up. What is wrong with me? I can draw circles. Close enough. It was really bad. We're gonna give up. We're gonna draw some exceedingly crappy circles. Okay. That's two. All right. Can you guess? I would have to unfold my keyboard, and I'm being really lazy. I should make myself just like a blank thing next time. Okay, so can you guess what we're gonna do? Two waves, okay. What are we gonna do with these two waves? Addition, okay. What were we doing up here? We were finding phase difference. So maybe we're gonna do delta phi as the phase of our second wave minus the phase of our first wave, rather than the phase between different wavefronts of the same wave. We're going to do different waves. So for example, if we look at this point right here, G, point G, okay, can you tell me the phase with respect to S1? So if we presume this starts at 0, and then this is crest, 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 what would the phase at G, the phase from source 1 is what? And he says 8 pi. 8 pi is also what I think. Remember that each crest is 2 pi in between. So this would be 2 pi, 4 pi, 6 pi, 8 pi. And every point along this ring would be at 8 pi. Yeah, there you go. 8 pi. Okay, what about from the blue. Ten pi. Yep. Okay. So I'm going to make a note that these are identical waves. They don't look identical, but pretend they are identical waves, which means they have the same lambda, the same f, same v, same amplitude. They can have different initial phases. Phi naught does not have to be the same. Okay. So what is the phase difference between the wave from source 1 and the wave from source 2? So the options are 2 or 18. Remember, it's difference, so you want to subtract. You were going to add the displacement, but what we're doing right here is we're doing 10 pi minus 8 pi is 2 pi. And what do you expect us to get at that point? Double crest, double trough, 0, something else? Double crest. Yep. Double crest. Okay. What about, let's say, point right here, point H. What is delta phi at point H? This is G. Okay, you're going to get a double trough, yeah. What is our delta phi? Okay. 4, 6, 7. 2 pi. Yeah. So it's 2, 4, 6, 7. 2, 4, 6, 8, 9. So it is 9 pi minus 7 pi equals 2 pi double trough. So they have the same phase difference, but one's a double crest and one's a double trough. Why? Symmetry? Okay. So, same wavelength? Yeah. So I would think about what is going to happen. What will these look like? Exactly half a period later. So whatever is a crest is now a trough. Whatever is a trough is now a crest. So I'm going to draw. Oh, geez. Right. So this is what it looks like now. T over 2 later. And there's one more for fun, right? And the same thing is true for our other one. What was a trough is now a crest. Circles of the Parkinson variety, yeah. These are really bad. It's because the palm rejection sucks, so I can't rest my palm. I have to like hover. Okay. So now, same waves, small amount of time later. I do need the fancy gloves. Yeah. So now at G, my delta phi is still, right? So this is going to be like pi, 3 pi, 5 pi, 7 pi, 8 pi, 5, 3 pi, 5 pi, 7 pi, 9 pi, 10 pi. Still a 2 pi phase difference, but now it's a double trough. Right? Over here, this is still a 2 pi phase difference. Now it's a double crest. Right? So what's happening here is you're asking whether these delta phi tells us whether two waves line up. Right? So we have a crest, trough, crest coming this way. We have crest, trough, crest coming this way. And the question is, will this trough arrive at the same moment this trough arrives? And if it does, then this crest will arrive at the same time this crest will arrive. And then this trough will arrive at the same time this trough will arrive. And then this crest will arrive at the same time this crest will arrive, etc. Does that make sense? So what you end up seeing is the result will be double crest, double trough, double crest, double trough, double crest, double trough. Wait. So you end up with a wave with the same period, frequency, lambda, etc., but twice the amplitude. And this happens if our delta phi is 2 pi, or 4 pi, or 6 pi. Right? If they are off by a whole cycle. Does this make sense? This idea? There are some decent videos of this kind of thing. Let's see. There's any good ones. This one is good for like later. So this is kind of what we're looking at, right? The view from above makes it a little easier to see. Maybe this one. Right, so here we have a wave. Okay, ignore all the slit related stuff. Doesn't really matter. But if you look at a particular location,